Okay, this is the end of our third-ish chapter with our counting subsets. We're going to look at our set C, where C is going to be the elements containing the elements A, 3, 90, Y, and 7. And we're going to ask ourselves, how many subsets of C have both 90 and Y? It's very important for you to see the word and. This means we are not going to be counting the sets that have 90 but do not have Y. We are not going to be counting the sets that have Y but do not have 90. We need to have the sets that have both of them, not just one of them. So how are we going to do that? Well, first let's use our quicker method, our 2 to the power of n method. Well, what is this going to be? Well, we know 2 to the power of n is just saying, well, the number of possible subsets is going to be 2 to the power of however many options you have. When we were counting how many total subsets there are, we had 5 options to choose from to pair or not pair them. So this was 5. But we're not looking at all of them. Not all of them are going to be available to choose. We specifically cannot choose 90 or Y. We are forced to have them. They are fixed elements. We have no choice whether they're going to be in our subsets or not. They have to be in our subsets or not. So we really only have 3 choices. We have A, 3, and 7. So our n in this case is going to be, in fact, 3. 2 to the power of 3. So what is this going to be? 2 to the power of 3 is equal to 8. This means that the total number of subsets of C that have 90 and the letter Y as elements is going to be 8. Let's try this with our choose method. So with our choose method, let's remind ourselves that originally when we said we had all of these subsets, we wanted to choose all of them, means we can choose 5, we can choose none out of the 5, which is going to be 5, choose 0, and we can choose 1 out of the 5, and we can choose 2 out of the 5, and we can choose 3 out of the 5, and we can choose 4 out of the 5, and we can choose 5 out of the 5. That is how we got the total number. But again, this 5 meant we had 5 choices. Out of the 5 elements, we can choose none of them, 1 of them, 2 of them, 3 of them, 4 of them, or all of them. But we no longer have that. Instead of having the ability to choose 5 elements, we only have the ability to choose 3 of them. We're fixing 2 of them. So 5 total minus the 2 means 3. That's where we get 3. So we're really asking ourselves how many ways to the set, let's say 90 comma Y, how many ways can we add something to them? So that's going to be 3 choose 0, meaning we can just leave it like this, 90 and Y. 3 choose 1, meaning we can add something here. We can add one thing out of these 3 options, A, 3, and 7, to our set, including 90 and Y. 3 choose 2, which means we can add 2 elements here on top of our already existing 90 and Y. And we can do 3 choose 3, which means we can add all 3 of our elements, A, 3, and 7, to our 90 and Y. We cannot choose we cannot choose 3, choose 4, and 3, choose 5. There's no way, because think about it, if I give you 3 numbers, how are you going to choose 5, right? There's not enough numbers to get that many choices. So our total answer is going to be equal to the sum of these 3 notations. Well, 3 choose 0, there's only one way to choose nothing, to be with 90 and Y. How many ways can we choose 90 and Y to have one of these 3? The answer is going to be 3. How many ways can you choose 90 and Y to have 2 of these, whether it's A and 7, or A and 3, or 3 and 7, so on and so forth? Well, let's compute that. That's going to be 3 factorial over 2 factorial times 3 minus 2 all factorial. This is going to be 1 factorial, so it's just going to be 1. 3 factorial over 2 factorial is actually just going to be 3. So we know that this 3 choose 2 is equal to 3. Then we have 3 choose 3. 3 choose 3 is going to be 3 factorial over, oh, I don't even need to compute this, actually. How many ways can we get 90 and y to be in a set with all of them? Only one way. So this is going to be 1. What do we get? 3 plus 1 plus 3 is 4, plus 3 is 7, plus 1 is going to be 8. That is exactly the same answer we got with our first method. But this method, of course, makes a lot more sense. You can choose 0 of the free elements to be with the 2 fixed, 1 of the free elements to be with the 2 fixed, 2 of the free elements to be with the 2 fixed, or all of the free elements to be with the 2 fixed elements. In a subset, of course.